Hi, my name is Dale Maley. In this short video, I'm going to run through two examples of how to use a simulation program for mechanical linkages called MotionGen. A little background on myself. I like designing and building hand-cranked marble machines. I discovered a free simulation program called linkage.exe by David Rector. You can download and try that out if you do a Google search for linkage.exe program, or here's the actual internet address. You can also see my other YouTube videos I've made on how to use that program. A few days ago, I found another free simulation program for mechanical linkages, and it's called MotionGen. If you do a Google search for MotionGen, you can find the program, and it actually runs on your web browser. You don't download a program. Here's the actual internet address of where you can get MotionGen at. Unfortunately, all software has a learning curve associated with it. And when I'm trying to learn how to use a new program, I like to have some video examples from other people to let me quickly learn how to use the program. Now, there are some other videos out there produced by the people who made the simulation program, but I decided to make this video to help people quickly learn how to use the software. So I'm going to do two example linkages step by step. I'm going to do a really simple slider crank model first. I'll follow that up by a more complex 4-bar linkage. So let's add a simple slider crank mechanism using MotionGen simulation program. So the first step is we're going to add a link. So go over to the right and click on that. And then we'll go to the origin and we will draw about a 2-inch link. Now let's go down and click on the bottom of that link, and it's going to give us the coordinates and just what we wanted. We want to be at the origin, x equals 0, y equals 0. Now let's go up and click on the top, and we want that to be 0, 2, and it is. So we're in good shape. Now let's click down at the bottom and let's go over. A pop-up menu comes up. Let's ground that one. Okay. And then let's add a rotary actuator. So we click on that and a little pop-up menu comes up. Now the speed is 10 RPM. That's okay for this exercise. We do want to switch directions, and the default direction is counterclockwise, so I want to reverse that. And that's all we really need here. And at this point, we ought to be able to run the simulation. So let's go down to the bottom, and we got a play and a stop box here, so we'll hit play. And oh my goodness, it's working so far. And remember, we chose clockwise, and that's what it's doing at the RPM that we put in. Now let's say that we want to change the speed. This one's a little tricky. It's not a shown menu item, and if you click on the center, you don't get an option to change it. So it took me a little bit to figure this out, but there's a couple of little spots off, like to the right here. Click on that, and that original menu pops back up, and we can change the speed from -10 to say -5. Just hit enter, close it. Now let's hit play. Now it's going at 5 RPM, as you can see here. Okay, so you can scroll in and out to change the size on the screen. So we're going to do that. Now we need to add a horizontal bar for the piston to slide on. We'll go over and pick a link, and we'll run it from about here over to say here. Now this is a little different how you make a sliding link on this one. So we just picked a regular link. There's another option over on the right menu, which is add a slot. So you click on that, then go back and click on your link. Bingo, you got a slot. Now there is, you can actually draw a link with a slot. I'll show you that. Let's go over and click over here. It has draw slotted link. So we'll draw it down here, and there's a slotted link. Okay. So either way, to get a slotted link. But the key thing is you have to have a slotted link for a slider mechanism to work. So let's get rid of this one. We'll click on it, and there's a trash can up here, and it went away. Okay. So all we have now is the connecting rod. So we'll go over and click on draw a link, and we'll take it over to, say about center there. Now, one thing that we have to, or you notice here, there's no play option for the simulation at the bottom, and that's because the linkage is not completed. So what do we need to complete it? Well, we need to anchor the two ends of the horizontal slotted rod. So click on the left hand side, pick ground, go to the right hand side, hit ground. Now you notice the play option for the simulation comes up at the bottom down here. So let's click on that. Here we go at very slow 5 RPM. And everything's okay. We come on around, and we made the slotted part long enough that everything's okay. So it works. So let's click stop. Now what if we'd messed up and on that this end, what if we hadn't made that long enough? Okay, like that. Let's shorten it up on the right hand side. Okay, so notice what happened to the blue circle that traces the end of the crankshaft. It's no longer a complete circle. It's only part of the way around. And if we click on play, what happens is the software reverses direction when it hits that stop at the end. Same thing down here. It's probably going to hit the end, and it's going to reverse direction just like that. So let's hit stop. Let's go fix it. Move it over a little ways. And gee, notice what happened. The blue circle became completed. And by the way, let's go speed this up. So click over to the right of that. Let's go to a -20. And let's hit play. And here it goes. So pretty easy to draw a slider bar linkage mechanism in here. There's only a couple of tricks involved. One is you have to have a slotted link, as shown on the right. And the other thing, when you add the rotary motion down there, if you want to change anything after you initially add it, you're going to have to click on one of those dots beside the circle of the rotary actuator. It's about the only tricks I think you need to know to do this particular mechanism. Now let's do a little more complex linkage, a 4-bar linkage with a sliding piston. So the first thing we're going to do is go over to the right menu and click on link, and we'll start down at the origin, and we want to make this about 3 inches long. Click on the bottom of that link, and X and Y are 0, 0, which is what we want, and click on the top, and we have 0, 3, which is what we also want. Now let's scroll out a little bit ways, and let's add a 7-inch link to go up to the rocking beam. Let's go over to the right, draw link. We want that at 7. 7. And let's click on the bottom of that. And that's 0, 3, which is what we want. If we click on the top, 0, 10. So that would be the 3-inch crank plus the 7-inch link would give us 10. So that is correct. Okay. let's go to the crankshaft, the center, and let's ground that or anchor it. And then let's also add an actuator, rotary actuator. I want the direction though to be clockwise. And let's bump it up to say 15 RPM. Okay. Now notice it won't, you can't play the simulation right now because it's not a complete linkage. The top up here would flop around if you could run it, but it won't let you run it because it's not completed. Okay, so now we need the rocking beam, and we want it to be a total of 18 inches. So go over to draw a link. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think I got it, but let's go check. Check on the left hand. It's at 0.10, which is what we want. And then what we're going to want on the other end is going to be 18, 10. Oops, I'm one off. So let's back it off an inch. Try it again, and we're at 1810. That's what we wanted. Now that rocking beam, we want it to be grounded in the center of that link. So there is over on the right hand menu, there is a place, and it's called Add a Joint. So we'll click on that. We'll come over to the center. Bingo! It added a link in the center. Now the coordinates we want for that would be x equals 9, y equals 10, so by golly, it's correct. Alright, let's go ahead and anchor that point. Okay, we did. Now notice that the mechanism, the simulation will run because we have the play and stop icons down at the bottom. So it will run the way it is, so let's go ahead and run it. Uh-oh, it didn't go all the way around. And you can tell that there's the blue circle down at the crankshaft doesn't go all the way around. So darn, didn't quite work. I want it to go all the way around. Well, let's change this. Okay, I want to change the color so we can see it better of this connecting rod. So let's go to red. Now I see it. So instead of 7 inches, let's go 7 1/4, which means, I think we need to take the crank and change the end of it. Instead of 3 inches long, we'll make it 2.75. Okay. Now we're going to change this connecting rod to 7 1/4. So the total is going to be 10 up here. So we're still okay there. Okay. Now we look, and simulation icons are still there, so it's a good linkage. But now the blue circle goes all the way around the center of the connecting rod, which is what we want for this application. So let's play it. Here goes. Everything's good. So we'll stop it. Now we want to add the right hand side connecting rod and then have that go to a piston. So let's add a link. And we won't do it directly below the end because it's hard to see, but we'll take it down, say to there. And I just picked a regular link, so I have to go choose that option, which add slot, and I click on it and it added a slot. It's kind of hard to see, but it did. Okay, let's click at the top. Oops, something happened here. Okay, we're going to ground that. Let's go down and click on the bottom. Ground that. So now it's grounded. Now we need to add the connecting rod. So we start on the right hand side of the rocking beam. Going to make it roughly as long as a connecting rod on the other side. There. And it's kind of hard to see, but there is a blue line over here on the vertical to track the motion of the piston. However, notice that our circle down here on the crank doesn't go all the way around, which means we're going to hit. So let's just run it. Verify that what's going on. So you see the piston go up, but it hits the end up there, which causes the program to reverse directions. So let's stop. We need to bring that on up a little more. Take it up to here. Now our circle's all the way around down here, so that means now we're probably okay on the motion. And you can see the two arcs. I think the ends swing roughly 45 degrees looking at them. So let's hit the play button. Here we go. Over on the right, the piston's coming up. Down it goes back down. So let's stop it. We've completed it. I would like to click. I had to zoom in on the rotating thing to get the menu to get the little dot to show up to click on. Let's take that up to say minus 30. Minus 25 RPM. We're going to have it go a little bit faster. Okay, here we are. Kind of get it centered here so you can see it. Hit play. Now she's running faster. Everything works great. So, not too difficult to make this 4-link slider bar setup over here, running a piston, 4-bar linkage, running a piston. So all in all, not too much of a learning curve involved with using this program. So some closing thoughts on this short video. The MotionGen program is relatively easy to learn how to use. In my experience, it's very hard to design a 4-bar linkage mechanism if you're just using a 2D drafting program. So simulation software like this becomes very valuable if you have to design a 4-bar linkage. So in summary, this short video explains how to use the MotionGen simulation software. There's an easy example of a slider crank mechanism and a more complex 4-bar linkage mechanism. You can see my other videos that has many different types of marble machines and their associated mechanisms. Hopefully this video helps you on your projects. I hope you enjoyed the video, and please subscribe. Thank you.